What's up guys, it's Simon Fiaz and today's video is on AQA level chemistry acids and bases question paper. I think after this I only have NMR spectroscopy and then that's it. I say that's it, but then I need to go through all of them again to identify any questions that I don't understand or any weak questions. Go through that with you guys. Yeah, so let's get on with this question paper. It is a very long question paper, so yep. So question 1, explain why H2O is not showing a KW expression. Is because this thing here is constant. That's why it's constant. Concentration H2O is constant. So in value KW increases, temperature increases. Okay. So this one is a challenging question because it requires a lot of thinking, right? So I know the forward reaction is endothermic because that's positive. So that tells me the forward reaction is endo because positive VE. So the forward reaction is endothermic. If I increase the temperature, equilibrium is going to shift to which side? Well, it's going to shift to the endothermic direction, to the forward direction, to oppose the increased temperature, hence decrease the temperature. So therefore, I'm going to get more of this. And what is KW? KW is the concentration H plus and my concentration H minus. So I've got more of that. KW is going to increase. So yeah, that's why it says that. So explain why value of KW increases, temperature increases. So I'm going to say forward reaction is endothermic. Forward reaction is endothermic. Actually, equilibrium is endothermic. In forward direction, equilibrium shift to right hand side to oppose the increase in temperature. The reason I say that's quite difficult is obviously it's not that difficult, but compared to the rest of these, which you'll see later on, it is because a lot of these now, like question C, part C, very easy. Expression for pH of water, the recalling of a expression, which unfortunately you just have to memorize. A lot, like I think almost 90% of chemistry is is memorization. And then it says calculate the pH of pure water at 50 degrees Celsius. So how do I calculate pH? pH is minus log 10H plus, and I'm given this, and it says at 50 degrees Celsius. So at 50 degrees Celsius, KW is that. So I'm going to write this down. KW equals concentration H plus times by concentration of H minus. I obviously want to find out the concentration of H plus, right? But what does it say in the question? It says pure water. So if it's pure, then the concentration H plus equals the concentration of H minus. I'll put that on the flashcard if I was you. So therefore the expression now becomes KW equals concentration H plus squared, and that's the part where most students trip up on. Then the rest of it is easy. KW therefore H plus is the square root of KW at 50 degrees Celsius. So square root of 5.48 times by 10 to the power minus 14 times by 10 to the power minus 14, and then I just substitute that value into the pH expression, and you get your answer as 5 point, what does it say? It says 2 decimal places, so 5.55. And then it says again, explain why, no, not again, explain why water is neutral, concentration H plus equals concentration of H minus. Okay, use figure 1 to give the true pH value in a meter. pH meter reading is 5.6, so you go to 5.6. I might need to zoom in a bit. Can I get a... No, I don't think I can get a a ruler on this. So you go to 5.6 and you just draw it down, and I can already see that is 5.6. And there was a silly mistake that I made. That is not the answer. The answer is 6.63. I misread the mark scheme. 5.56 was the answer for this. Okay. Suggest why the pH probe is washed with distilled water between each of the calibration measurements. To wash off any residual solution which could interfere with the reading. So when the volume of sodium hydroxide added is smaller as the endpoint is approached. Very nice question. Very, very nice question. It's just the wording to avoid missing the endpoint, right? To avoid missing the end point. Say what all three of the indicators are suitable for this titration. I don't even need to look at this. It tells me they are suitable. It's just asking me state why they are suitable. Well, because all three have a color change in the vertical part of the endpoint. So all have a color change within the vertical part of the titration curve. Okay, now we're going on to some big boy questions. Okay, it says this much sodium hydroxide added this much hydrochloric acid, calculate pH final solution to 100 degrees Celsius. It gives me KW and it is 5 marks. Okay. And with acids and bases, it doesn't matter, if you master these small kind of questions, you memorize these, you memorize all the content. If you don't know how to attack these kind of questions, you're gonna lose marks. 100%, what a question like this is gonna come up. If acids and bases come up, which it will, more than likely, you will get a question like a 5 marker on this. And if you can't get at least half marks, you're probably not going to get that A or A star which you wanted. So it says, okay, calculate pH final solution of this. So what are we working with? We are working with a hydroxide, OH minus. We've got hydrochloric acid, HCl, and if I can fully remember. Alright, so the first thing we're going to do, obviously, is work out the moles. Right, so I'm going to work out the moles of sodium hydroxide. I'm not going to show the working out. It's a waste of time. Obviously, in the exam, you have to show the working out, but not right now. Work out the moles of sodium hydroxide, and I get 7.25 times by 10 to the power minus 3. Then I work out the moles of HCl, which I get as 3.75 times by 10 to the power minus 3. Okay, but what it wants me to do is it wants me to find out the pH of the final solution. So let's think about this, right? I've got sodium hydroxide, I've got hydrochloric acid. Obviously, the sodium hydroxide dissolves, so I'm just left with the OH minus signs, and this HCl dissolves, so I'm only left with the H plus signs. Right? So I can clearly see OH minus signs is in excess. If I can work out the number of moles of OH minus signs as in excess, the amount remaining, then what I can do is then I can work out the the concentration, then I can work out the concentration H plus signs, and then I can work out the pH. And it's just a methodological approach. The first step in these questions is usually the hardest. Once you've worked out moles, what do you do next? Well, I know that reacting with each other. So what I'm left with is going to be 3.50 times by 10 to the power minus 3 moles. That's obviously moles, but I don't care about moles. I care about concentration. Moles is concentration of volume, concentration of moles, divided by the volume, which is the volume of what? Well, it's the volume of the total thing, isn't it? So it's going to be divided by 61.25. Yep, 61.25 times by 10 to the power minus 3. That will give me the concentration at OH minus signs, but I want the concentration H plus. Well, I know Kw equals concentration H plus times by concentration OH minus signs. So then I can work out the concentration H plus by doing H plus, concentration H plus equals Kw divided by concentration OH minus. And then once I've worked out the concentration H plus, then I substitute it into pH equals minus log 10 concentration H plus. So yeah, it is relatively easy. Once you know that you have to subtract this from this because this is excess, I want to find out pH of final solution. So I need to find out the moles of hydroxide ions, then concentration, then concentration H plus, then you find pH. Then it's relatively easy, and you get 12.76. Calculate the mass in grams of sodium ethanoate. That must be added to this much to produce a rough solution of pH this at 288 Kelvin. For methanoic acid, pK is this. 5 marks again. So it wants me to calculate the mass of sodium ethanoate that must be added to this much of methanoic acid, which is this, to produce a buffer solution with a pH this. And it even gives me pKa. So I'm going to do a lot of things before I even fully understand what's going on. I'm going to work out the moles, obviously, of the methanoic acid, which is HCOOH. 25 divided by 1000 divided by 0.100. Then I'm going to work out the concentration H plus, which is 10 to the power minus pH, which is 10 to the power of minus 4.50, 4.05. Then I can even work out Ka. Ka equals minus log 10 of pKa. I haven't gone through this in a while, so I might be wrong. I don't think I am. So then therefore it's just going to be minus log 10 of 3.75. That's not going to get you 3 marks though, right? It's not. Maybe 2 at best. So you worked out the moles of HCOH, worked out concentration H plus ions. You could just leave any calculator. I don't want to really put it in standard form and any of that. Work out Ka. Ka is not. Yeah, it is not that. That is incorrect. Ka equals 10 to the power minus pK. Unfortunately, again, that is just something you have to memorize. And if you forget it like I did, or confuse it with another formula, then you will lose all your marks. So you get that. You've got the concentration H plus ions. You've got Ka. So what do I do now? Well, I know. Let me write down the Ka expression. Ka equals the concentration HCOO minus times by the concentration H plus over the concentration HCOOH, COOH, and I want to find the mass of this thing. Have I got the concentration of HCOH? No, I've got the moles. Can I work out the concentration? Yes, I can. Very easily. Do I have Ka? Yes, I do. Do I have the concentration H plus signs? Yes, I do. So now it's just a putting in your calculator kind of thing. So I'm going to say Ka, which is 10 to the power minus 3.75. Times by concentration of ethanoic acid, which is 25 divided by 1000, times by 0.10, and then actually let me work that out first. 25 divided by 1000 times by 0.100. Okay, I'll keep that answer now. So I've got 10 to the power minus 4.3 minus 3.75 times by my answer over, well, I want to divide it by, because moles of concentration, volume concentration is, oh, no. Silly me. Silly me. That is the, that is the concentration of methanoic acid. That is already the concentration of methanoic acid. Methanoic acid. So what am I even doing, right? So 10 to the power minus 3.75 times by 0.10 divided by concentration H plus signs, which is 10 to the power minus 0.05. We're not done there though, because I want the mass. I've currently got now the concentration. So moles is concentration, volume, moles is concentration. So I've got the concentration times by the volume, 25 divided by 1000. Right, that's the moles. I don't want the moles, I want the mass. So moles is mass over mR. Mass is the moles times by the mR of sodium ethanoate, which is 1 plus 12 plus 16 plus 16 plus 23, and you get 0.34 grams. You know, I remember I was extremely confident with this topic. Like, I think it was like in February, March time. Yeah. And you know, once you like stop doing these past paper questions, you're gonna forget it very soon. Anyway, yeah, so the main mistake is don't just do the normal approach, find out moles, rearrange to find out concentration. Sometimes it gives you the concentration of the acid. It's just trying to trick you out. State the meaning of the term weak acid. Acid partially that partially dissociates in water, releasing, forming H plus ions. Give an expression for acid dissociation concentrated from nucleic acid. Oh, that's a memorization question. This, I'm gonna say this is a memorization question as well, because you need to know, like, you need to know how to express it. So what happens is, so you've got, for example, if we look previously here, you've got this, so it dissociates, you've got a H plus ion, and you've got this thing on the bottom, right? So I'm gonna have C2H5 COO minus, I'm obviously gonna have H plus here, then on the bottom I'm actually gonna have the acid C2H5 COOH. In my opinion, that's again a memorization question. Then it says, okay, now we're talking. A student dilutes this much propanoic acid. until the total volume is 100 centimeters cubed. Calculate pH of the dilute solution of propanoic acid. Give your answer to 2 decimal places. Okay, a student dilutes this much until the total volume Okay, a student dilutes this much by adding water until the total volume is 100. There are specific questions in acid and bases that literally are specific methods which you should memorize in order to attack these kind of questions. So what I need to first things to work out is I need to work out the new concentration. And it's quite clear to me from that, because it tells me the student dilutes this much until the total volume is this. So that's the total volume. I want to work out the new concentration. What I can use is the dilution formula. Dilution formula. Where it's very simple. There are other formulas, but this one is very simple. C1 times by V1 equals C2 times by V2. I want to work out C2, concentration of C2. So I'm going to do C1, 25 divided by 1000, times by V1, no, times by 0.500. It's the other way around, but it's fine. Divided by 100, divided by 1000. And I should get, well, obviously 100 divided by 1000 is 0.100. I get 0.125. Perfect. So that is the concentration of the propanoic acid. Yeah, C2H5. COOH. Perfect. Just by using the dilution formula. Okay. Now I need to work out, well, what am I working with? I'm working with Ka, right? I want to work out the pH. pH is minus log 10 to concentration H plus. That is the expression. pH equals that. So in order to do that, I need to work out H plus. In order to work out H plus, I need to now rearrange this equation. So I'm going to say Ka times by this whole thing. I'm going to say let this equal Y, just to make my life a bit easier. I don't know if you can do that in the exam, but I'm going to do that. Let this equal X, and that equals the concentration H plus. Do I know any of these things? Do I know Ka? Yes, it tells me the Ka is this at 25 degrees Celsius, and it wants me to work out yeah, that is Ka, okay? So you don't need to worry about that. So I've got that out of the way. Do I know the concentration of C2H5COOH, which is Y? I do know that. I just worked that out. Do I know the concentration of C2H5COO minus? I don't know that. But it tells me that well, it tells me from the beginning. We know propanoic acid is a weak acid. And again, I would put this on a flashcard. So if I'm given a weak acid, then I assume that concentration H plus equals the concentration of the OH minus ions. Sorry. If I have a weak acid, then I assume the concentration H plus equals concentration A minus. There we go. So I assume that the concentration H plus equals the concentration A minus. So with acids and bases, a lot of people think, oh, it's just practice questions. It really isn't. You know, that is a big component to it, but the most important component is memorizing these formulas, these expressions, you know, confident rearranging, memorizing these assumptions. So then when you're given an exam question, you know, because these exam questions can ask you about any kind of thing and you're expected to know these assumptions. So now I know this, then I obviously know that these two are the same. So therefore the concentration H plus equals the square root of Ka times by that. I know both of them, and then I just substitute the pH and I get 2.89. 2.89. Okay. A buffer solution with a pH of 4.50 is made by dissolving X grams of sodium propanoate in a solution of propanoic acid. Define the volume of the buffer solution 500 centimeters cubed and define the concentration of the propanoic acid is 0.250 moles per DM minus cubed. Calculate X in grams for propanoic acid. Ka is that, and it is 6 marks. So this is a real exam past paper question. They give you a 1 mark definition, give you a 1 mark given expression, then they give you a big 4 marker, and then a 6 marker back to back. So that's 12 marks. You don't know how to attack both these questions, you've lost 10 marks already. That's a full grade. You need to know these kind of questions, guys. And the only way to is practicing them. So buffer solution pH of this. So first thing I'm going to do is obviously write down the things that I have memorized. Okay, perfect. Second thing I'm going to do is I'm probably going to okay. Now I need to think, right? It tells me to find the concentration of propanoic acid. And I want to find out X in grams, where X is the grams of sodium propanoate. So I need to rearrange the Ka expression. C2H5 COO minus H plus. You know, don't be scared of what's this Na doing. That's obviously going to dissolve to this anyway. H5 COOH. I want to work out X. So I want to work out this. So I'm just going to rearrange it. So Ka times by this divided by H plus equals that. Okay, do I know Ka? Yes, I do. So I ticked off the box. Do I know concentration H plus? Yes, I do. I ticked off the box. Do I know the concentration of C2H5COOH? Yes, I do. Tells me right here. Ticked off the box. Literally, that's it. That's so easy. It's giving me everything basically. Yeah. What I would normally do if I've never seen this kind of question before, I would work at the moles, 500 by 1,000 times by this. No, it tells you the concentration. It basically is a trick tactic to see whether you are reading the question properly or you're just following a method of which you normally just work at the moles all the time. You work out that, you've got the concentration of this, but I don't want the concentration, I want the moles. Then I can work out the mass. So moles of concentration volume to the moles is going to be this answer times by the volume, which is, the final volume is 500 centimeters cubed. So 500 divided by 1,000. And then I want to work out the mass, moles mass of mR mass is the moles, times by the mR of sodium propanoate, which is 96. And then I get my final answer as 5.13 grams. Easy question, actually. Honestly, an easy question. Now that I look at it, you know, work out concentration H plus, rearrange the K expression. It gives you everything. You work out the concentration of this. Then it's just how well are you exposed to these kind of questions. You know, that's the concentration. So then, first things are first, I need to work out the moles by doing concentration volume. Then I need to work out the mass. No, then I need to work out the MR. Then I work out the mass. And then I give it to appropriate number of significant figures. Question 4. Which statement about pH is correct? The pH of a weak base is independent of temperature. Independent of temperature of a weak base. So pH is not independent of temperature. That is false. At temperature above 298 Kelvin, pH is less than 7. I'm not even sure about that. So let's work out these two, and if these two are wrong, then it must be B. It's a realistic approach if you're not sure about a question like this, multiple choice question. So the pH of this, approximately 0.30. Nitric acid, so it is HNO3. Minus log 10 of that. It is minus 0.30, so that's wrong. The pH of sulfuric acid, so minus log 10. Minus log 10 of 0.10 times by 2, because sulfuric acid's got 2, 0.698 is greater than minus log 10 of 0.10. No, it's actually less than. So that is incorrect. That is incorrect. I know that's incorrect, therefore must be B. Question 5. A 0.10 moles per minus cubed aqueous solution of an acid is added slowly to 25 centimeters cubed 0.10 moles per minus cubed aqueous solution of a base which acid base has the highest pH at the equivalence point. So if it's going to have the highest pH at the equivalence point, I want a big difference. Big difference. Now, with the thing about HCl and sodium hydroxide is HCl is a weak acid. Sodium hydroxide is a weak base. Same with D as well. Ethanoic acid, again, is a weak acid. It is a weak acid. But sodium hydroxide is a strong base. No. Hydrochloric acid is a strong acid. Ethanoic acid is a weak acid. Sodium hydroxide is a weak base. Ammonia is a strong base. Hydrochloric acid is a strong acid. Ethanoic acid is a weak acid. Sodium hydroxide is a strong base, not a weak base. So if sodium hydroxide, ammonia is obviously a weak base, so I'm going to cross that out. Because what I want is I want to have either a really strong acid and a weak base, or a really weak base and strong acid. The thing about this one is I've got hydrochloric acid, which is a strong acid. But I've also got sodium hydroxide, which is a strong base. So it's actually not going to give me extremely high, the highest pH at equivalence point. Therefore, it must be A. The reason it's A is because ethanoic acid is a weak acid. Sodium hydroxide is a strong base. Strong base. Okay. Question 6. Which is the correct concentration of sodium hydroxide moles d minus cubed as pH? It gives me everything. Well, not everything, obviously, because it gave me everything, then I will work out. So what is a KW expression? Again, an expression you have to memorize. So I want to work out the concentration of sodium hydroxide, so I want to work out the concentration of OH minus signs. So therefore, concentration of OH minus signs equals KW divided by concentration H plus. KW is that. Concentration H plus is 10 to the power minus pH. This is a fairly simple question, you know. I've seen questions, guys, with these multiple choice where it's got one step, another step, another step, another step, multiple processes happening at the same time, and it's ridiculous. So it's 1.00 times by 10 to the power minus 14 over 10 to the power of minus 14.30. I get 2, so the answer is D. I got 1.995, therefore rounds to 2. Explain why the student is correct. It's because the concentration H plus equals concentration H minus. And I'm going to show you that they actually reuse past paper questions, because if I scroll up, here, explain water neutral, because H plus equals OH minus. So instead of saying y is neutral, I just said y is the student incorrect. Okay. So because it's pure water, and it tells me that from the explanation, therefore Kw is no longer, that's not Kw anymore. That's incorrect. Kw is now this. Because H plus equals OH minus. Therefore concentration H plus equals square root of... No. I want to work out the K value of Kw. So Kw equals H plus, well, H plus equals 10 to the power minus pH, 10 to the power minus 6.67. So it's going to be 10 to the power minus 6.67 all squared, which is 4.57 times by 10 to the power minus 14. Nice 4 marks. Okay, use your diagram to calculate the value of Ka. And one thing, I've noticed from these past papers is they love to include diagram questions, especially with Arrhenius equation and thermodynamics. That topic especially. But you might expect to see a couple of them in acids and bases, like this, for example. So how would I work out Ka? How? How would I do it from a graph? Well, I can see, okay, what I can see from this graph, this titration curve, sorry, not a graph, is that I've got the pH when there was no sodium hydroxide, 0 sodium hydroxide added. So when there was 0 sodium hydroxide added, the pH was that, right? So that was with pure acid. But what is the key thing about pure acid? Ka over your concentration of propanoic acid, which is that. How do I know this? Because just once we use some logic, like if 0 sodium hydroxide is added, then that tells me that's pure acid. That's the pH of pure acid. And if it's pure acid, concentration H plus equals concentration A minus. Therefore, I get this expression. I can work out the concentration H plus because it's 10 to the power of minus pH, which is 10 to the power minus 3.0 from the titration curve. And then I just substitute it in, and then I've got Ka. 1.25 times by 10 to the power minus 5. 3 marks for that, Iman? Yes, because you had to find the concentration and then use your logic to interpret the information from the graph, which is fairly difficult for a lot of students, including myself, which indicates most appropriate for reaction part B. So if you go back here, we can see this is the vertical part of the part of the curve. Right, so what does it go from? It goes from, let's say start from here, 7 to, let's say, here, 11. 7 to 11, that's what I'm looking for. That's the range. So that's not going to work. That's not going to work. That's definitely not going to work. So therefore, it's that. That's how you do it. It's very simple with these kind of questions, but it gives you the information. Then yeah, 7 to 11. Because if you might be wondering, Iman, what about bromothymol blue? Well, bromothymol blue, it starts. If I look at 7, it finishes at 7.6. So it's not going to go through 7 to 11, is it? It's not going to be that appropriate, the most appropriate for this indicator. Whereas cresylphaline goes through 8 to 9.8, which is a lot more in the vertical part of the titration curve. Okay, 6 marks. Big buffer question. You shouldn't prepare the buffer solution by adding this much salt Kx to this much of a solution of weak acid Hx and mixing thoroughly. You shouldn't add this much potassium hydroxide to buffer solution. Calculate pH of buffer solution after adding potassium hydroxide. So, um, um, okay. It's getting hard now. Very difficult. Very difficult. I'm adding the salt to this much weak acid. I want to work. Okay. Alright. So let me construct a Ka expression. So at least I know what's going on. And there we go. It gives me that information. There we go. This is the concentration of the weak acid. So I'm going to write that down. Is it though? Yeah, it is. But I don't want the concentration, I want the moles. So the moles is going to be 0.0. How do we do it? In the mole scheme, I think it goes like N of Hx, the number of moles. 0.0500. Then I'm adding this much to a buffer solution. So let's think about it, right? I'm adding potassium hydroxide to a buffer solution. With this kind of stuff, you're adding this much and you're subtracting this much. That's what you need to know. So I'm adding this much, I'm also subtracting this much. Well, if I think about 0.050, Well, actually, even 0.0136. 0.0136. If I subtract 3.00 times by 10 to the power minus 4, I'm not going to do that, am I? I'm going to do 0.05, subtract this, then this 0.0136, add this, because, right, because I really want to explain it as well, because I've got this moles of the speak acid HX. If I'm adding hydroxide ions to this buffer solution, what's going to happen? Well, the hydroxide ions are going to react, obviously. And then what is the remaining moles of HX after? Well, I'm going to subtract it, right? But with the salt, I'm not going to do that. I'm going to do the opposite. I'm going to add the moles of the hydroxide, potassium hydroxide, to the buffer solution. Because with the salt, KX, or you could look at it this way, which is the way I do it. Once you work out which one you're subtracting from, then the other one you're going to have to do the opposite, which is adding. And I think that's the best way to look at it. Once you worked out the number of moles of each of the new ones, so the number of moles of HX after you add potassium hydroxide, so you're basically subtracting, and then for the other one, the opposite, where you're adding, you work out the H plus, and then you work out the pH. That's 4.30. Use a mathematical expression to explain this constant pH even when diluted. Constant pH even when diluted. Well, if it's going to have a constant pH, well, then the concentration of the H plus ions. Okay, yeah. If it has got a constant pH, then the concentration H plus ions is no longer an expression. Because it's constant, it's got no effect. So it's no longer an expression, and I'm just left with x minus over hx. That's your ratio. Just plate for molecular of this. This is how I like to do it. H2SO4. And then it says HSO4 minus ions acts as a weak acid. They dissociate from this and this. Give me the equation. So the H2SO4 dissociates to HSO4 minus plus H plus. Then I've got the HSO4 minus SO4 2 minus plus H plus. Again, I'll memorize these two equations. She's required to make this much aqueous solution. Describe a method to make a solution. Okay. Okay, I'm going to skip this question because it's a purely practical question, and I don't think it's really relevant to. It's just waste use. Okay, I'll just briefly go through it. I'm obviously gonna write down everything you need to go through, but the way by transfer method, which you should know by now, which is way solid transfer. Um, so you can find a precise mass of the solid. Then you dissolve it in water. Dissolve in water. You transfer with washing, and then you make up the mark, and then you get the rest of the points. Now, with these kind of practicals, just memorize the full practical. So anytime you get a question like this, you just copy and paste it. You just write down the whole of the practical. You're gonna get the full marks anyway. Okay. Okay. Bit of a weird one. 6 marks, and then a 2 marker, and then it wants me to say calculate value of Ka, and it said the units of Ka, which I've never seen in a while. I've never seen that before, have I? So Ka is the concentration of, in this case, HSO4 minus H plus over HSO4. Actually, no, it's not, because it wants me to calculate the value of Ka for this. Right. Something's wrong. Whenever it wants you to calculate the value of Ka for this, when you're doing the Ka expression, that automatically is your denominator. And I would again put that on the flashcard. Because why not? If you know all the tricks, you know all the methods, the approaches to any kind of question, you're sorted, aren't you? So then you get this. I don't know why I put this H here. That's obviously false. It's SO4 minus H plus step that. So yeah, anytime you start to calculate value of Ka for this, that is always the denominator, and then you can work from the numerator from there. Numerator. Okay, I can now work out concentration plus signs, which is 10 to the power minus 1.72. What else can I do? I can work out the moles of the NaHSO4. How do I do that? Well, it's the mass, which is 0.605 grams over the MR, which is 32.1 plus 1, no, 32.1 plus 23, 55.1 plus 64, 109.1 plus 1, so 100 and sulfur is 32, isn't it? It's 32 plus 23, 55. 55 plus 64. 59 plus 60. 119. So 120. 0.1 actually. Yep. You get that as 5.4. 10 by 10 to the power minus 3. And then, because it's a weak acid, initially, the concentration SO4 2 minus. Oh, before you can do that. Uh, 100 semis cubes, I need times by 10. And then Ka therefore is going to be concentration H plus squared over that, which you give me 1.17 times by 10 to the power minus 2. The units moles per t minus cubed, and it's always going to be this, remember, because you're working with concentrations. So with Ka, you're going to have moles per t minus cubed squared over moles per t minus cubed, which can be moles per t minus cubed. Some sodium sulfate is dissolved in a sample of solution from part D, saying why this increases the pH of the solution. So what does sodium sulfate have? If I ask you guys that question, a very simple question. What does sodium sulfate contain that is important in A-level chemistry? It contains sulfate ions. And what are sulfate ions? It contains SO4 2 minus ions, right? And if I'm adding SO4 2 minus ions, which is here, then I'm going to have a bigger numerator. As you know, if I think about concentration H plus, right? You could think of it like that, but you could also think of it like this, right? These two are going to stay the same. That's going to go to the left hand side. I'm dividing by a bigger number. So if I do 10 divided by 2, I get 5. And I want to just show you guys what's going on. But if I do 10 divided by 5, I get 2. So what's the thing that's changed? Same numerator, it's just denominator. If the denominator gets bigger, I get a smaller number. You might be wondering, Iman, that's obviously extremely, everyone knows that, that's basic. But apply the same logic to this. Therefore, the concentration H plus is going to decrease. And if that decreases, pH increases. So it is, these kind of questions do require a lot of, application, a lot of brain power. So equilibrium shifts to left. Two minus. And if you even go back here, it gives you the equations here which you go through. So if adding more, then equilibrium is going to shift this side, so you're gonna have less of this. That's how you could look at it. Which indicator should be used in a titration by concentration solution methylamine using this much of HCl. Methylamine. Let's draw that out. Methyl group. I've got NH2. I've got a methyl group, right? So methylamine is a weak base. Methylamine is a weak base. Methylamine is a weak base. The indicator methylamine is a weak base. So, I know obviously hydrochloric acid is a strong acid. Fully dissociates. So you can see with these questions, it's complicated. So now you've got a weak base, strong acid. Then you have to go back to your memory of what a weak acid, strong base pH titration curve even looks like. So again, memorization. I don't know what it looks like, so I'm going to get the textbook real quick. In my budget, man, this is so complicated. It's A levels, man. And A level chemistry is one of the hardest A levels. So yeah. So weak acid, strong base. No, weak base, strong acid. Weak base, strong. Wait, yeah, weak base, strong acid. So the pH curve should look something like that. That's the vertical part of the curve. That's where the pH is 7. So this is the vertical part of the curve. So anything really that's good in between there, or not phenolphthalein, not that. The highest it can go up to is 7. So I'm left with this. And that's 0. So it basically, well, that's 1. So basically, I'm looking at like 2 to 5, basically. That's the main part, right? So therefore, it's going to be B then. Bromophenol blue. Tricky question. Yeah, very tricky multiple choice question. But yeah, all you have to identify is which one's is it weak base, strong acid. Then you have to memorize these curves as well, these titration curves, and then write it down, and then approximately 7 to 1, 5 to 2, so therefore B. It's all about approximations and probabilities and all of that. Question 10. And K is that. pH is that. Okay. Rearrange the expression. H3COO minus H plus over Ka. I've got the concentration as an 08 times 0.136. I've got the concentration H plus ions, which is 10 to the power minus pH 3.7. over Ka 1.74 times by 10 to the power minus 5. And that would give me the concentration. .06. Okay. In different buffer solution, concentration of ethanoic acid was that. The concentration of ethanoate ions was that. This much sample of sodium hydroxide was added to this much. The buffer solution calculate pH buffer solution after sodium hydroxide was added. So same thing like previous question, but if you're adding, it gives you a buffer solution, then it tells you you're adding hydroxide ions, which might moles of this, moles. So the only difficult part is that I've got concentrations. I want moles, so I need to work out moles of ethanoic acid. And to do that, I need to do times by the volume, which is 500 divided by 1000. So I get the moles of ethanoic acid, 0.130. I get the moles of the sodium ethanoate, 0.605. Okay. Now I'm adding sodium hydroxide, right? So if I'm adding sodium hydroxide, it's going to react with the acid. So therefore I'm going to subtract 7.00 divided by 10 to the power minus 3. So I'm basically minusing, so what's the remaining left of this, because it's reacting with this. And then the ethanoate ions, so I'm just adding them on because they already had ethanoate ions. So I'm just adding them on to this. Once you've spotted which one you're subtracting from, the other one is always the opposite. So you could just memorize that fact. Then I get 0.123, 0.0675 as a new moles. And then all I do now is put it into the, rearrange the Ka expression to find out H plus and substitute values in. 4.50. The difficult part, guys, is this first part. I'm adding hydroxide ions, so it's going to react with the acid, so I'm subtracting the hydroxide ions. And then therefore the other one I'm going to do the opposite because it's in equilibrium. Then it's easy from there. And then trust me, it's easy from there. Rearrange the Ka expression, substitute your values in, your new values, and obviously you do need to cover them concentrations, but you could just assume they cancel out anyway. And yeah. Suggest a pH range of suitable indicator for this titration. I would say 10. Now I'd start from 7. I'd say 7 to 10. That's what I would do. And the mark scheme says 7 to 10.2. I didn't even look at the mark scheme, and it says 7 to 10.2. But allows any range 2 values within this range. So yeah, that's fine. Next, calculate concentration Hx in the original solution.
Window put the open.
Hello, Manchu. You okay?
My window's open, right?
Yeah, it's open.
Cool.
Yeah, how's your exam? Whose are these?
Not mine.
Here.
Bubbles. How to do this? So the original solution. I don't think the curve is any use to me, so I'm gonna have a look at this. So the original solution. Gives me Ka. Gives me concentration of the hydroxide ions.